Hi, everyone. I'm going to go over some of the definitions related to fractions and then help you with multiplying and dividing fractions. We will also talk a little bit about how you can pay attention to the answer choices since you are taking a multiple choice test to either find your answer or to double check that you have the correct answer. So first of all, let's do some definitions. The numerator is the number on top, and the denominator is the number downstairs. So it's the number on the bottom. A proper fraction has a smaller number on top of a larger number. And an improper fraction, the scandal, that one has the larger number over the smaller number. Okay. And then we have a mixed number, and that is a whole number. And I'm going to say plus an improper fraction. I'm sorry, a proper fraction, because that's what we actually do. For example, if I had something like 3 and 1/4. The 1/4 could be thought of as a decimal, as 0.25. So the value of 3 and 1/4 could be thought of as 3.25. Then when we want to go from a mixed number to an improper fraction, it's a three-step process. So we take the first step is to multiply the bottom number times the whole number. The second step is to add the numerator. And the third step is to keep the denominator. So let's see what we get. We have 4 times 3, and that's 12, plus the 1 on top is 13, and then we're going to keep the 4. This is the same as 3 and 1/4. Okay, then if I want to do the reverse, let's say I want to take 13/4 and convert it into a mixed number. Well, one way you might do it with the long division, the 13, the guy on top, I always say he gets the house. So we'll put him inside the house and the denominator goes on the outside, trying to get in. 4 times 2 is 8. 4 times 3 is 12. Okay, so we're going to multiply 4 times 3, get as close as we can to 13 without going over, and we have 1 left over. Our new whole number is the whole number of times that 4 could go into 13 without going over. The 1 remainder is our new top number, our new numerator, and we're going to keep the denominator, the guy on the bottom. 13 over 4. The 4 goes in 3 whole times, and there's 1 of the 4 left over. Let's see what we want to do next. How about multiplying fractions? When I want to multiply fractions, I keep in mind the rule to simplify before you multiply. This way, I'm working with smaller numbers to decide if there's a number that they have in common instead of working with really large numbers. Here's an example. We have got it right over here, so I have it already worked out. 3/5 times 10 over 17. And I could just multiply across the top and multiply across the bottom, but then I would have to check and see if there's anything that I could divide the top and bottom number by the same number evenly. It's easier when I'm working with smaller numbers. I see that 3 and 17, those are actually both prime numbers, and it can be very handy to already have your prime numbers memorized. I recommend knowing your prime numbers if you decide that you want to get faster with fractions, but it's certainly not necessary. The 5 and 10, hopefully you recognize that those can both be divided evenly by 5. And when that happens, this simplifies to a 1, and the 10 simplifies to a 2. If a number on top and a number on bottom can be simplified this way, go ahead and try to do that before you multiply. Then you multiply across the top and you multiply across the bottom. We're left then with 6 over 17. And again, 17 is a prime number, so I know I'm definitely done there. Okay, what's next? Then division. Division is just like multiplication, only you have to make a trip to KFC, get some good old Kentucky Fried Chicken. We're going to keep the first fraction the same. We're going to flip the second fraction, and we're going to change the division to multiplication. So Kentucky Fried Chicken. Here we have 10 over 11 divided by 5 over 22. Okay, I'm going to keep the first fraction the same. I'm going to flip the second fraction. And then I'm going to change the division to multiplication. Now we go back to our rule. We're going to simplify before we multiply, and that way we'll have a reduced or simplified fraction when we're all done. I see that the 10 and the 5, again, can both be evenly divided by 5. So that simplifies that to a 2 and a 1. The 22 and 11, those can both be divided by 11. What we're left with then, after we had something so scary looking to start out with, has ended up being very simple. 4 over 1, which is the same as 4. What do we do if we have mixed numbers and we want to multiply those? Well, unfortunately, you must convert your mixed numbers to improper fractions before you can multiply or divide. You have a choice. You can work with those improper fractions and still do the simplify and multiply. You could also use the answer choices. To help. So let's see what that's going to be like. What if I had 1 and 5/9 times 11 and 4/7? And let's say these are our answer choices. This is actually one of the problems from the pages I give you in the math section M. Again, I could convert this into, what would that be? 9 plus 5, 14/9 times 77 and 4, that's 81/7. Oh, and this will actually simplify quite nicely. So we can simplify by doing the 14 will become a 2 and the 7 will become a 1. 9 divided by 9 is 1, and 81 divided by 9 is 9. I end up with 2 times 9 over 1 times 1, which leaves us with 18 and the answer choice D. I'm going to go ahead and show you another possible way of solving this. This one was pretty nice and easy to do, but another option could be that you take the 1 5/9, and 5/9 is the same as 5 divided by 9. Put that in the calculator and you get 0.555555555. So I'm going to round it to 3 decimal places, 0.556. And then we can take the 11 and 4/7. The 4 divided by 7 is equal to 0.571 and then some more digits, but I'll stop at 3 decimal places. 1 5/9 then can be written as 1.556. 11 4/7 can be written as 11.571. I can multiply these by each other. And if I put those in my calculator, it actually comes out to be 18.00. So again, we get the answer choice of letter D. If it had not been something that straightforward, then, for example, it might have been 11 point something. Well, then I would know that the only one that had 11 and the point something would come from the fraction, then I would have known that this was the correct answer. We're going to look at another example and see how this can work. Let's take a look at 4 6/7 times 1 1/8. And our answer choices, we've got a few, well, 2 that start with the number 5. So if our final answer ends up being 5 point something, then we will evaluate those 2 possible mixed numbers. If not, if it starts with a 38 or a 1 point something, then we know it'll be one of those 2 answers. Again, I could do one style where I actually solve it by hand. So 7 times 4 is 28, plus 6 is 34 over 7. And 8 times 1 plus 1 is 9 over 8. Now see, this is a lot uglier looking because it, it doesn't have anything that can simplify side by side. If I do this, then I end up with 306 over 56. And now it's starting to get a little trickier. This comes out to be 5.46 if you take 306 divided by 56. I could also solve by hand knowing that the first value, the whole number would be 5, and then I could see what remainder was left over. Let's see, it's going to either be A or B. Why don't we take a moment and think about which one might be 0.46? 0.46, well, that's approximately the same as 5.5, right? Or 5 1/2. I'm going to be looking for an answer that starts with 5 and where the top number times 2 will be approximately the same as the bottom number. Now these look pretty close, so let's take a look. If I did 13 times 2, that's 26. That's close to 28. So this is a possible choice. What we're doing right now is probably a new concept for you to be thinking about these fractions and what kind of decimal values they would give you. once you've practiced this a few times, it gets a lot easier and you're able to narrow down your answer choices pretty quickly. The other one, 5 and 7/19. 7 times 2 is 14. This is less close to the bottom number, to 19. Then 26 is to 28. So I have a feeling that this is going to be our correct answer. We can check. 13 divided by 28, it ends up being 0.46. So our answer is, right? Yeah. It comes out to be 5.46. And I think that's correct. Let me just double check what 13 divided by 28 is. Oops, now you guys know that I play solitaire while I listen to books. 13 divided by 28 is, yep, 0.464. Okay. So our answer then is going to be letter A. Now, how do we do this one? Well, this one I did a combination where I turned them into improper fractions, multiplied across, and saw that I was going to have a mixed number for an answer. And I still approximated trying to figure out which one of these two would be the answer choice. It certainly couldn't be this one or this one. You also could have done the long division and figured out what the remaining fraction was, and then it would have simplified to 13 over 28. Let me show you a second method that could be used. In this case, we go ahead with our 4 and 6/7, and we see that 6 divided by 7 is 0.857. So this will end up being 4.857. And we're multiplying that times, oops, 1 and 1/8. And 1 divided by 8 is 0.125. So this ends up being 1.125. 4.857 times 1.125 is equal to 5.464. Well, we already know that 5 and 13 over 28 is also equal to 5.464. So we know, again, that A is our answer. Personally, I like this method better. I find it to be quicker than trying to work with improper fractions and trying to get a number and a fraction to go with it. Again, I still would end up trying to analyze answers if there's more than one choice. The nice thing is most of the time, if you come up with something like 5.46, often there's only one answer choice that's 5 with a fraction. So it makes it a lot quicker. You don't have to worry about trying to approximate the fraction so much. It's a nice little shortcut considering you're taking a multiple choice test. And I feel like it's still not that far from what we would do in real life. I would look at this and I'd still think, oh yeah, that's about 5.5. It's just a matter of picking which fraction comes out to be exactly the same. And there's a long way to turning 0.46 into a fraction. We could have eventually gotten close to that, but working with the decimal sure is pretty quick and easy. I think that was all that I was going to show you for this. And then I have a second video to help you with doing addition and subtraction with both solving it using standard rules for fractions, and then also taking advantage of being able to convert them into decimals and comparing them with the answer choices. So if you like these kinds of methods, then feel free to check out my other video. Thanks for watching.